This one's for Kobe. And our topic is zero. Where did it all start? The origin as a number or placeholder. Let's rewind. 2020, 1,000 years ago, 2,000 years ago, 3,000 years ago, 4,000 years ago, or even 5,000 years ago. Sumerian and the Babylonians. They thought, what represents nothing? Well, we obviously need something. Let's think. Look at our bubble. What is that? A triangle? No. Cheese? No. A wedge? Maybe so. As Robert Kaplan suggests, they used wedges as empty number columns for positional value. They call it, or I call it, Mr. Placeholder, 101 or 1 wedge 1. Let's fast forward 600 years. Concept of zero in America. The Mayans, they were math geeks, in fact. But they never used a placeholder in any equation. Instead, Mr. Placeholder actually belonged in the calendars, which is considered one of the best technological advances. But we know today, the wedge didn't stay Mr. Placeholder. In fact, it became a number in India. Origin late 10th century, where they actually used it for many operations in math. Zero means shunya, or empty, like the jar shown. The credit of the number zero will always belong to India. The wedge will still live on, though, in our case. Now Mr. Placeholder is not a wedge, but the number zero. So I would probably say that zero had an impact. It wasn't small or big, but it was huge. Life without zero, no calculus, algebra, or algorithms. Still don't believe me? Let's try long addition then, without zero. Alright, 146 plus 284. Well, that becomes 6 plus 4, but we don't have a zero. What's happening? Let's go back to Mr. Brahmagupta. Well, he says, that's what I thought. You kind of need the zero, don't you? Time to talk controversy. What is dividing by zero? Let's take two ends. 1 divide 1 equals 1. 1 divide negative 1 equals negative 1. Now, 1 divide 0.001 equals 1,000. And the opposite, negative 1,000. As we approach zero, we say 1 towards 0 equals infinity. 1 and to negative 1 to 0 is negative infinity. Doesn't that make it undefined? Yes. Now what about 0 factorial? First find a pattern. Let's take 3 factorial equals 6, 2 factorial equals 2, and 1 factorial obviously is 1. Now we see divide 3 and divide 2 from previous. Going by this pattern, we also see if you divide by 1, you get 1 divide 1, which is equal to 1, right? Now, 0 to the power 0. Caution, this just confuses everyone. Way 1. Let's list the powers, 1 to 1, 0.9 to 0.9, all the way to 0.4 to 0.4. As we expect, they're all decreasing. But when we turn around, it's 0.3 to 0.3, 0.2, and all the way to 0.001. We almost get 0 to the 0. It's almost equivalent to 1. Wait, 2. Let's take 0 to the negative fifth, all the way 0 to the negative 1. And as we know, 1 over 0 is undefined from before. Yes. But is 0 to the 0 so 1 or undefined because it's 0 over 0? This we don't know for sure. Yep, I officially explained nothing.